Hello, this is Richard Collins, your instructor in ATM101 Weather and Climate of Alaska here at the University of Alaska, Fairbanks. Welcome to Unit 10. In this unit, our reading will focus on weather systems, while our investigation will focus on water and humidity. These two topics are linked because as we think about weather systems, precipitation and storms, clearly the behavior of water in the atmosphere is critical in determining what kind of weather we get. Our study of weather systems will focus on air masses, fronts, cyclones and anticyclones. These are the building blocks with which we understand how the atmosphere behaves and how weather evolves in the atmosphere. Understanding these building blocks is critical in creating a model for which we can forecast the atmosphere. The reading for the week draws on Chapter 10 of Weather Studies and Chapter 6 of the Climate of Alaska. Chapter 10 of Weather Studies discusses weather systems. It discusses weather systems as a mid-latitude phenomenon, and this is a bias from the European and lower 48 approach. It's a bias based on the idea that at that time scientists separated mid-latitude weather from tropical weather because the Coriolis force is present in mid-latitude weather but not in tropical weather. It's very weak at low latitudes near the equator. This is not to say that mid-latitude weather is distinctly different from subpolar and polar weather. The Coriolis force is at work at our latitudes, and therefore our weather is described by the mid-latitude model. The distinction scientists are making, or meteorologists are making, in calling it mid-latitude weather is to differentiate it from tropical weather. It's not necessarily to differentiate it from polar weather. So while it calls itself mid-latitude weather, we are indeed studying the processes that matter here in Alaska. The scales of the weather systems is called the synoptic scales, hundreds to thousands of kilometers. It is not the only scale that defines the weather. There are regional and smaller scale processes at work, and we highlight some of those at the end of the unit. In the lecture screencast for this week, I highlight what I think is important. Again, there's a lot of detail in the book. I also add some conceptual overviews to give you a more complete picture of the pattern of the life cycle of the cyclone and how upper air and lower air information is important in understanding what's happening at the surface. And finally, I go into more detail about vorticity. It's not that I'm trying to give you lots of exam material about vorticity, but the language of vorticity is used in the language of weather, and it's important to have a conceptual framework for why it matters. Don't forget to complete and submit your concept questions this week based on your benchtop investigation. There's no screencast this week, but you will be submitting concept questions instead for credit. If you have any questions, don't hesitate to contact myself or Cameron. Thank you and good luck.